Let's finish the lab for HSRP and VRRP. In the previous lab, we set up the basics, and now we need to fix this configuration because we need to add what is known as delay for the preemption. Remember that always use delay when using preemption, because otherwise your first hop redundancy protocol will be subject to your network flaps. And then we're going to use object tracking. With object tracking, we can actually sense how your network is behaving, and if there are certain catastrophic events on your network, you can take some action. For instance, let an active device relinquish control of being active and let the standby to take over. So in this case, remember that for VLAN 100, 101, and 10, switch 3 is active and switch 4 is standby for this part of the network. And for the headquarters, VLAN 100, 101, and 110, again, we have Nexus 3 as the master device and Nexus 4 as the backup. Whereas for VLAN 102, which is the guest VLAN, in this blue network, switch 3 is standby and switch 4 is active. Whereas in the green network, Nexus 3 is backup and Nexus 4 is master. So this is configured this way in order to achieve some sort of load balancing. So switch 4 and Nexus 4 are actually switching packets. They are not idle. And so we're going to go and do this in the lab. If we have enough time, we're going to configure VRRP for IPv6 that we didn't configure in the last lab. Okay, remember that we configured several VLANs with HSRP. In this case, notice that we didn't configure delay. So notice also that in VLAN 100 we have two groups, one for IPv4 and one for IPv6, and there is no delay in the config. Also in switch 4 we have the same. Nexus 3 we are not using preemption delay. On VRRP version 3 neither. So let's configure that. Okay, let's go for switch 3, and we are going to add a minimum delay of 30 seconds with the command standby, number of the group, preempt delay, and minimum 30 seconds. So this means that we're going to wait for any event to in the event of becoming or having or reaching a highest priority, we're going to wait 30 seconds before taking over. We're going to configure that here as well. So we are adding preempt delay minimum 30 for all VLANs. So now let's configure object tracking. Notice in the diagram, for instance, for switch 3, the two interfaces that connect switch 3 to the upstream network is router 1 and router 2, router A2 and router A1, that get connected to switch 3 to gigabit 01 and gigabit 02. The same applies for switch 4. So we're going to configure object tracking for gigabit 01 and 02. So we're going to use the command track and then create a number, and then we are going to set up a delay as well. So this object number 1 will become down if gigabit 01 is continuously down for 10 seconds, and this object will become up if gigabit 01 is continuously up for 10 seconds as well. So this will avoid getting subject to flapping on this interface. And the same applies for object 2 and gigabit 02. Now let's apply this tracking to HRP. Remember that tracking makes more sense when it is applied to the active device. So switch 3 is active for VLAN 10 with VLAN 100 and VLAN 101. Notice that we are decrementing 6 for each object So if you issue show standby VLAN 10, for instance, it has a configured priority of 110 and 2 tracking that will each one decrement 6 from this value. So if these two objects go down, this priority will end up as being 98. In that case, switch 4 will win because switch 4 is configured with a priority of 100. Now let's configure the same for switch 4. In this case, it will only apply to VLAN 102 because switch 4 is active for VLAN 102. Okay, I still need to create a tracking in switch 4. We're going to track the same interfaces. And now let's see, for instance, show standby VLAN 10. It is not tracking, but VLAN 102 is tracking because this is configured on active devices. And in the case of VRRP, this is configured in master in devices that are masters for certain groups. So let's do that for Nexus 3 and Nexus 4. In this case, let's see if the command is the same. Track number 1, interface, gigabit. In this case, is Ethernet. Let's see which ones are Ethernet 1 and Ethernet 2. Line protocol. Up, delay, up 10 seconds, down 10 seconds. And then track 1, track 2. Interface Ethernet 1, 2, line protocol, delay. So now we have to configure that within the VLANs. So for instance for VLAN 10, for VRRP group 1, address family IPv4, and this will be object track. The command changed a little because we're configuring Nexus now. Decrement 6 and object track 2, decrement 6. So we'll have to configure that for VLAN 10, VLAN 100, and VLAN 101. So let's do that for VLAN 100 and VLAN 101. And in the case of Nexus 4, we are going to configure also the tracking. Track, object 1, interface Ethernet 1.1, line protocol, delay up 10, down 10, and then track 2 for Ethernet 1.2. Notice that these are two upstream interfaces in the diagram. And then we're going to configure that for VLAN 102, for which Nexus 4 is the master device. Okay, so this is how interface VLAN 102 looks like. If we can issue show VRRP version 3 VLAN 102. The state is master, and we have these two tracks. So in the event of Ethernet 1.1 and Ethernet 1.2 going down, then Nexus 3 will take over. And it will wait 30 seconds because we are using a delay. Okay, let's now configure version 3, the IPv6 for VRRP version 3 that we didn't do in the last lab. Show run interface VLAN 100. Okay, let's create another group within VLAN 100. VRRP version 3, group 2 for address family IPv6. We will have a priority of 110, preempt delay minimum 30 as a best practice. Remember that you can decrease this number, but then as this number goes lower, the more you can subject your first hop redundancy protocol to your network flaps. So let's also track these two. And then for the address, we have to provide a link local address. So the easiest link local address is this as the primary. It will let you provide a global IPv6 address as well. For instance, this one. And then let's apply an IPv6 address to this interface. This will be a global IP address. And that will be it. So this is how we're going to configure this. Next, let's configure that in Nexus 4. So let's go for switch 4 and configure VLAN 100. So this is how it ends up looking. Okay. Notice that let's see how these devices behave. Let's go to the end user device, PC10. Notice that these devices use something that is known as Slack. These devices will gather enough information from the IPv6 network in order to be configured automatically. So, for instance, this device gathered this part of the network from the closest router. The closest router generates network advertisements or router advertisements that include the first 64 bits of the network. And then the other 64 bits are figured out through an algorithm that I believe it is called EUY64, where the MAC address of the device is taken into account to create 64 bits to create the 128 bits that belong to corresponds to an IPv6 address. Then we have the MAC address that belongs to the default gateway. So let's see if we have an interface here, for instance, loopback 1, where we have set up a dummy IP address for VRF users. So this will help us test if the default gateway is routing. So I could use ping IPv6. Let's test this address first. Ping IP 8 VRF users. I think I'm doing something wrong. VRF users 8 ping 6 8 VRF users. Okay, that's it. Let's see if we can ping that from here. And then let's see, something is wrong. Let's trace it. Something is wrong. Let's see if the access B switch show rich domain 100. Okay, from gigabit 5 I am seeing this MAC address. Okay, it was a matter of time. So this is just a way to configure VRRP version 3 with IPv6. Just use the easiest link local address that came to your mind, that comes to your mind, and that's it.